Okay, so this is part of after you get done with TELPAS. The station numbers are at the top.
This is what?
Station numbers are at the top. For the quiz that's metals, non-metals, metalloids, please use your periodic table. As you go to answer it, I gave you number 5 because I don't think people know how this necessarily works. So I gave you 5. On the second half of this worksheet, what I would do is label these with the numbers that correspond with down here, because this is all really small. So like 5 is the lanthanide series, 6 is the actinide series, 10 is your metalloids. So I would number the words up here that correspond with the names in the bottom part. To help you out one more, where are they at? 4 is the transition metals. So just labeling the parts of the periodic table based on the vocab at the top. On the back, you do not have to do this section because we already did that section. And then with this part, a key will be posted to WebEx, sorry. But you're basically going to define what makes an element, explain how you find the atomic number and what is it and the importance of it. A block here for the symbol explaining it's not just the name, but sometimes it's where it's found or countries of origins, the elements names, there'll be some facts about that, and then the atomic mass, how do you solve it. And then down here at the bottom there's 3 questions. These 3 questions will not be included in the key. Well, the answers will not be included in the key, so you'll need to figure out the answers to them based on your knowledge of periodic table and atomic structure. So that's page 1. Page 2 looks like this. So this is station 2. This will also be part of the grade that goes with it. This will be the one that I'm like really gonna grade. So on the top here with the oxygen box, this top number is the atomic number. So we're just labeling what are these parts called. This is my symbol, the name for it, and then the mass. And then in parentheses I'm gonna write that it's rounded because we don't want to deal with all of those decimals, right? Then atomic number equals the number of protons or electrons. I'm not going to write the whole word out. And the atomic mass is my protons plus my neutrons. So then the first half of this is pretty straightforward. Remember we talked about taking stuff out. So on the box it gives you most of the answer. So you'll write the missing piece of it, and then you will solve the bottom parts down here. We did these. I think back to the work that we did last week that was this stuff. So it's basically a continuation. That's what all this is here. It's this here. So it's repetition, repetition, repetition. So for oxygen, using the square, so atomic number is 8, atomic mass is 16 because we round. Protons and electrons are all going to be the same. So 8 protons, 8 electrons, 16 minus 8 gives me 8. So a way that Miss Hubbard was teaching her kids is 8 man. So atomic number, protons, electrons are all the same, and then mass minus atomic number gives you the neutrons. So it's just another way to look at that guy. So then you, for the station for today, are going to do zinc, lithium, silicon, boron, and bromine. And then you can cross off basically the bottom 6, so you don't have to do magnesium through fluorine. And then for the periodic table basics, this one is the page that is the last 2 pages in it. They go together. And it has the little shark on it. and it says periodic table basics. The front part is more about explaining how this works. So step 1, you're going to fill in this card. We're going to do it here together. Step 2 is you're going to use colored pencils. And it says to color the cards, but I already cut them out and put them in the right order. So you're going to color this part based on information. So each of these tells you you're going to color sodium and lithium green, boron and aluminum orange, oxygen, sulfur pink, carbon and silicon red. So you're going to follow each of these and color them in as it says to color them in. The biggest piece here, the part that people are going to mess up, hydrogen is left alone. Hydrogen should be white. So if you color hydrogen, you've already messed up, and you don't get extra pieces. You don't have to do step 3 because I already put it together for you. It's on the back of the lab page that you have. Step 4, after you arrange them, glue them in. We already did that. Step 5, answer the questions. So the biggest pieces that you're going to have to come up with answers for are step 2 and step 5. So if you look at the box at the top, the number 1, and it tells you what everything is over here. So the number 1 for boron, you're going to write its atomic number, and boron's number is 5. Step 2, you're going to write the name in. Step 3 is the atomic mass, and remember we round it. So it's 11 because we're not going to write 10.0 or 10.811. And then for this number 4, you're going to determine protons, neutrons, electrons. So protons and electrons are going to be the same numbers. That's 5. 5. For my neutrons, 11 minus 5 gives me 6. Boron is a solid at room temperature. Trying to think. I think I gave you the Lewis dot structure for these. And the Bohr diagram, notice I wrote on here just the electrons. So there's 5 electrons. So 1, 2 go on the first ring. 1, 2, 3 go on the second ring. And then I am 90% sure that I did all the Lewis structures for you. And all the Lewis structures are the valence electrons, just around the symbol. So then if we look at the backside, using the periodic table that goes back here. So you'll have to do what I just did on all of these things here. So the lines are kind of fuzzy and faded sometimes, but we know what each of the lines are supposed to be. So it should be you just filling them in, each one across. So you're gonna, first and foremost, you're gonna have to go through and fill in all this for the top 20, nope, top 18. And once you get that filled in, then you're gonna answer the questions. So which elements have a complete outer shell? Give the name and the symbol. Give the symbol for each. There's 3 lines, meaning that there's 3 answers. What do you notice about the location of these elements? What group are they in? Number 2, which elements have only 1 valence electron? Give the name and the symbol for each. There's 1, 2, 3 lines, so there's 3 answers. What do you notice about the location or the group for each of these elements? 3, what do you notice about the number of valence electrons as you move from left to right? So as I move from sodium to magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, what do you notice about the valence electrons in it? So what do you notice about the outermost shell that's there? So it didn't do it, so we'll go back and look at that in just a second. 5, write the name at the top of the column. So you're going to write the names at the top as you go through. 6, what do you notice about the location of the elements in each family? So what do you notice about the groupings that are here? Which family would you classify hydrogen in? So we talked about how hydrogen doesn't really fit in a group very easily. So if you had to pick one, which of the families would you put it in? Which of the groups would you put it in and why? Which family are these elements located in? So remember the families is the group number. So radium, iodine, tin, and cesium. You're going to look at a periodic table from your notes, the big one that I gave you guys, and just write the numbers down that's there. And then predict the number of valence electrons based on location, or you can use the one in your textbooks. Remember we talked about this with the homework, the page that looked. I've lost it. The one that had the triangle on it, the homework that had the triangle on it, that's the part you're going to look at. Or if you're looking at your periodic table, most of them have a number underneath a number, so like 7, and then there's the 7B, 6, 6B, 3, 3A. So that number underneath is going to tell you your valence electrons. So once you get done with those questions, then you're going to look at this guy. So you're filling in number, symbols given to you, name, mass, protons, neutrons, electrons. With hydrogen, lithium, and sodium, it should just have 1 dot. Beryllium and magnesium should have 2. It's got 2 valence electrons. Aluminum and boron have 3 dots around the outside. Silicon and carbon have 4. Nope. Yeah, 4. Nitrogen and phosphorus, 1, 2, 3, 4, 5. Oxygen and sulfur have 6. Fluorine, chlorine have 7. Helium has 2. Neon has 8. Argon has 8. So that should be all the ones filled in. You will need to do the electron circles, but this is the same stuff from this worksheet. So you should just be able to go back and check the pieces that you missed. And then the last piece that makes this the lab for this. There's definitions on the back. So what is a family? What is a period? And then give the symbol for the following elements. So magnesium, iron, potassium, copper. Now you're going to give the names. Which period? Remember, periods run from side to side. Which group? Groups go up and down. And give the atom with the following characteristics. So a halogen, if you pull the periodic table that we did like this together at the end of the notes, we colored. So our halogens are going to be our group 17. So that's going to be anything from fluorine, chlorine, bromine, iodine, and astatine. So you just put the symbol down. So this group down here has lots of options. When you're done, you're going to take these 2 pages. You're going to make sure your name is on it, and you're going to turn it in. So this is an actual physical turn-in piece of paper.